Hi, Stuart again. Today, a little departure about what I normally YouTube about. We're going to talk a little bit about testing ETL pipelines. So, ETL pipelines are a big part of most enterprise systems. We are getting data from other systems in our enterprise, from our trading partners, from our customers. We may even be exporting data from our systems and sending them to trading partners and customers. So they're important. But they're notoriously hard to test. And so we've developed a strategy, a technique for testing ETL pipelines. And we've made a really simple example that you can download off our GitHub and build on. And so before we talk about testing pipelines, we need to talk about what makes a good pipeline and what makes it testable. And so here is a typical ingress, that is to say, import pipeline. And it doesn't really matter what the underlying ETL technology is. What matters is this sort of rough idea of what it looks like to build a good ingress pipeline. And that is this idea that we want to lift the data into the database. I'm using Microsoft SQL Server for my example, but this is pretty much true universally. So the first thing we want to do is lift the data off disk and into raw flat file tables that look like the layout that we expect from the input tables. And we'll show you what some of that code looks like in a second. And then we want to then go through a set of transform and edit steps until we end up with a schema that either resembles production exactly, like a staging schema if it's a very complicated scenario, or in our case, where the data that's in the holding table is sufficiently clean and suitable that we can write a series of SQL statements to update our production database. And again, this is an overly simplified example because we want to show off the idea. You're obviously going to have to do a fair amount of lifting, but there are three key concepts we want you to walk away from. One is lift the data off the disk and into raw files. Second is have a series of tables that allow you to do various transforms and data quality checks and things like that. And then lastly, merge that data into your production schema. And in curated environments, that production schema might be at a level 3. That is to say, it's an initial schema for consideration. And there may be additional promotion steps to lift the data in that schema, to cherry pick that data into a more reliable source that's used for reporting. And that might be your level 2 schema. And then you might have a purely analytic schema, a level 1 schema, that is used for additional reporting KPIs. And so that would have MOLAP, OLAP, star schemas, whatever your analytic structures are. So understand that that same process of promotion can be used to do promotions from level to level. To do our tests, we're going to do a riff on the arrange, act, assert pattern that's widely used in QA to include preconditions. A note is that both our ETL pipeline and our unit tests or our integration tests are all written as stored procedures. And the advantage to that for me as a demoer is it's very simple, but I have done a variety of very large, very complicated ETL pipelines, all in T-SQL. So you don't necessarily need to buy a big ticket ETL tool, although they can be very handy and deal with large volumes of data. But if you're just starting your ETL journey and you have relatively reasonable sized databases, so, well sub-terabyte, you may find that you can do both your ETL work, and you're testing entirely in T-SQL. So here is our production schema. It's called Bicycle. And it is the world's simplest schema, right? We have customers, we have products. Customers put in orders for products. The order table is the order header. The order detail is the enumeration of line items that they bought. World's simplest thing ever. Very simple table schema, very easy to understand. On our ETL pipeline is going to import orders and the resulting order detail. And it is going to ensure that the customer and products exist and that a minimum amount of data is populated in the order. In the real world, there's a lot of more quality checks we'd want to do. We'd probably want to have a much more complicated schema and so on. But I wanted to take a schema I had laying around, in this case, the bicycle schema, and reuse it for this purpose and just keep it as simple as possible so we can focus on the testing ideas. To support our schema, we've got a couple of other tables. We have the orders raw table, which is where the flat file is going to be lifted into. We have an error table. We have a table used to hold files to import. This could be a temporary table, but having a persistent table has the advantage of restartability. This is a common pattern where as your ETLs get more and more complicated, there is some value in transitioning from a temporary table to a named table. And in this case, we parked it in the ETL schema along with the raw table. And lastly, we have a configuration table. This is very common in databases. It's a set of name and value pairs that different stored procedures can use to fetch configuration about, in this case, the ETL. So we have a really simple little sample tab delimited data file, right? We have an identifier for the customer. In this case, we're matching on the email address. Again, that may not be the preferable method, but it really depends on what you can do. We have a foreign key to the product ID. We have a quantity, and we have an order date, which in this case is empty. And we use the BCP tool to help us load that data more effectively to generate a SQL FMT file. It's a format file, and you can see it lays out the definition of the flat file table. And so, top to bottom, it's saying, well, we're using SQL Server format version 14. We have 4 columns, and then it describes each of the columns and their terminators. And you can see that it's tab separated except for the last column, which is the carriage turn line feed. And the only text column is defined as a default collation, SQL Latin General. And so the advantage to this is that the actual stored procedure that invokes BCP can do so with this format file and do a lot of validation for you long before you lift it into the raw table. And so it can check types, it can check lengths, it can do all sorts of good things if we have a format file. So it's well worth investing in. And again, you can generate these. So if you make yourself a holding table that has the properties that match the raw table, run the BCP utility and make a format file, you then have a repeatable process. And the closest analogy I can come up with is that an FMT is to a flat file import as an XSD is to an XML import. In other words, it defines the layout and the types of data you expect. So here's our ETL pipeline. We have an initialization step, then we have a test to see if the initialization step was successful. In other words, are our starting conditions the way they should be? Then we have a step that iterates a directory specified in our configuration table and tries to find all of the CSV files to import and puts them into the import table. And then we have a stored procedure that then reads those files and loads up our raw data table. Once our raw data table is all loaded, in step 3, we run a set of business rules to validate the data is good, to provide defaults, to do general cleanup, and we reject rows we don't like. And then lastly, when our data is clean and ready to import into our production schema, we have this step that actually creates the insert or update statements. And in my case, they're all insert statements. Again, super simple example, and does the actual production load. And again, after each of those ETL steps, I have a test that asserts that things went as we expected in the preceding ETL step. So very simple pattern. So we have a demo. Okay, here we are in SQL Server Management Studio, and I've loaded up the file ad hoc test ETL1, and here is the ETL pipeline interspersed with tests and some startup stuff of our own. In the real world, you probably wouldn't want to truncate the order and order detail table, but I'm doing that to just have a clean start. And the other thing we're doing is we need to tell it where the data files are, and so we have an update statement to common configuration. If you decide to run this yourself, make sure that you change that path to be the folder where your CSV and format files are located. And then we have a series of steps. We run the ETL pipeline step and we run the test. And in some cases, we spew out queries just to get a view of the data. And then we conclude with sort of showing that the error log is in fact empty. And this is a set of happy path tests. In fact, I know that all my test data is good, but that wouldn't necessarily be the case in the real world. Again, this is somewhat of a contrived example, but it sort of shows you how things work. Let's show you a couple of the more interesting stored procedures. And again, you can download these and look at them yourselves. But one of the stored procedures that's really interesting is this one that is used to enumerate through a directory tree and fetch all the CSV files. And I will be the first to admit that I snagged this off of Stack Overflow and made a bunch of modifications. So if you're the author of this piece of cleverness, thank you very much. I found a whole bunch of different variants by a bunch of different people, and then I sort of hacked it up to do what I needed it to do. But notice that we are feeding the data folder variable by going to our common configuration. And if we do that, then this stored procedure will know what directory tree to enumerate looking for CSV files. And so we end up using a cursor. I know cursors are horrible, but there are moments where they're very useful. ETL is one of them. And we're using that to walk through the directory tree, find all the files, and find all the CSV files. And then as we find CSV files, we are inserting them into our files to import table, and then we keep going. And then in addition, as we find our format files, and in this case, we only have the one, we're going to update the configuration table with the format file path so that we have it for our future stored procedures. So we're doing dynamic discovery of the CSV files and the FMT files, assuming that we're starting in the correct parent directory. So this is worth looking at. It's sort of clever and can't take credit for it, but it is a useful technique for enumerating through file systems. The next stored procedure that's really interesting is this stored procedure that enumerates through the list of files that we've collected in that table of files, the format file, and we dynamically build a bulk insert statement, which essentially is executing the BCP engine. And we're telling it what file we want to soak up. and we're telling it the format file we discovered in the previous step. And it will go through and lovingly execute bulk insert into orders raw. And we'll do that until we've got them all. So now we have all of the data sitting in our ETL format raw table. And the next interesting stored procedure in our ETL chain is this one that does a bunch of stored procedure updates and checks to make sure that our data is valid. In the first block, we are cleaning up some of the input data. It's not uncommon that flat files will have stray characters in them, non-printing characters, whatever. And so we're going to get rid of the superfluous quotes and spaces and so on that would affect our results later on. And we are setting the order date to a valid date if it's null. And then we're doing some steps to make sure that our customers and products both exist. And if they don't, we're inserting rows into the error table. And that's a really good technique because in your ETL pipeline, if there are no rows in your error table, then presumably the previous pipeline step executed happily. And before each ETL step, you can check to see that that is still true. And if it's not, you can refuse to execute the step. One of the questions we get a lot is, how do you keep a pipeline step from executing if it shouldn't? And that's, setting a flag. The easiest way to do that is this existential check of if exists, right, to see if that there are no rows in our error table. So once we've done that, once we've gone through and fixed up our table and we validated our customers' products and quantities and so on, we're done with the business rules portion. In the real world, you'd probably have dozens or even hundreds of these stored procedures that would execute and do a lot more ornate checking on the data. But again, we're just illustrating some techniques in T-SQL. Very cleverly, you'll notice that we're using the object name of add@proc ID, for example, to get the name of the stored procedure. And that allows me to have this piece as a snippet that I can insert anywhere I need it. And then lastly, of course, we have the stored procedure that does the actual importing, and it does that by first checking to make sure that we have data to import, and then it checks to make sure that we should be running this step. So again, this sort of existential check that all is well. And then, whatever insert, update, whatever statements you need to do the actual population of the production data, and we run through each of the rows and do the appropriate things. And that is how that works. And so if we take a look at one of the tests, for example, you can see that fundamentally what we're doing is we're doing some sort of existential check on the previous step by doing a set of SQL queries. And then if we do not like it, we're going ahead and throwing, and we're going to, for each test, we'll emit pass or fail. Here is this test for step 3, which is looking in the error log and so on and so forth. So we can use the same techniques in our ETL pipeline to write our ETL tests. So here is the bicycle pipeline ETL front to back. We're already set to bicycles, so we'll go ahead and execute this block of statements, and you can see that it's pretty happy. We'll execute this to set our pipeline, and we'll go ahead and exercise each of our pipeline steps one after the other. So P0 test pass, that's a good sign. P1, so at this point, we should report that we found at least one file, and the P1 test is validating that that is true. Now we're going to load the raw rows using bulk copy. And you can see that we processed the file with that file name and that we ended up getting rows. Now we do our validation, and our validations all pass. And so we can see if we go look in the intermediate step of the table after the validation that in fact we now have dates in our date column and that the number of rows is still pretty much the same. And then we can do our actual execution of putting an order into the order table, and we'll show that the error log is happily empty. And if we go up here to tables and we take a look at the order table, you can see that in fact our orders went into the table. There we go, simple ETL test pipeline.